Hello, feeling a bit glum, so I'm here to do the thing that makes my heart sing, which is high school maths problems. So, we are inside the department's paper 2 from November 2022, and we are looking at question 5.1. Okay, given that root 13 sine x plus 3 is equal to 0, where x is some angle between 90 and 270, so that would be your second or third quadrant. Without using a calculator, determine the value of the of the ratios below. Okay, so first we need to figure out which quadrant exactly this angle is in. So we are going to rearrange this equation we've been given. So this is the same as root 13 sine x is equal to minus 3, which tells us that sine x is equal to negative 3 divided by root 13. So ordinarily, that would tell us that x lies either in this quadrant or this quadrant, right? That's where sine is negative. But because we've been told that x is in the second or third quadrant, then actually x is in this quadrant. It is in the third quadrant, it's between 180 and 270. So we can then go a bit further. Well, okay, we don't actually need to go further for now, because the first question just asks us for sine of 360 plus x. And if you add 360 to any angle, you're not in a new position on the Cartesian plane, you just return to the same position. So the sine ratio of that angle will be exactly the same as the sine ratio of the original angle, which we have discovered to be 3 over root 13, or if you believe, well, okay, and I'm one of those people who believe in it, rationalize your denominators. So this is me timesing by root 13 over root 13. Yeah, so that would be the first one. Now, where we do get a bit more interesting is where we now need to find the tan ratio of x. So this is where we're going to need to use our triangle situation. So I'm just going to draw what the angle x looks like. So we said it's going to be an angle in the third quadrant. So it's an angle like that, right? And for example, so since we know that its sine ratio is negative 3 over root 13, what that tells us is that the ratio between the y coordinate, okay, which we can see is negative, so we could say, for example, the y coordinate is negative 3, and the length of this, let's call it a radius, is root 13, right? So we know that the ratio between them is that. And you could pick any other two numbers, just as long as they would have this ratio. So you could pick 6 and 2 root 13, or 9 and 3 root 13, as long as when you simplify that fraction, it gives you this. Then you know that this angle is 6. So no matter where this point is and how long that is, well, not really no matter, but as long as the ratio between the y coordinate and the length of from the origin to that point, as long as that ratio comes to this, then we know that the angle from here to that line is always going to be whatever this x angle is, which you could of course work out on your calculator anyway, but we are not using a calculator. So right, so we want to find the x coordinate so that we can find tan of this angle, because tan is given by the y coordinate divided by the x coordinate. So to do that, we're going to use Pythagoras. All right, so we're going to use the fact that, well, we already know that the length of this guy is root 13, and we've chosen it that way, and then the length of this guy over here would have to be 3 units, right? And so we can say 3 squared plus some unknown d squared is equal to root 13 squared. So that is 9 plus, and this is what I'm calling d, that distance over there. So that will be equal to 13. So d squared is equal to 4. And therefore, since we're talking about a distance here, d will be positive 2. Okay, but now we want the x coordinate, and we can see that because this point is in the third quadrant, its x coordinate must be negative. So then we know that, so we know that the x coordinate of that point in our little scenario would be negative 2. Right, and so also tricky because we're already using x for the angle, so let me make that a bit more clear. So the x coordinate of our little point, our nameless point, will be negative 2. Anyway, okay, so tan of x will be equal to the y coordinate over the x coordinate, so that'll be negative 3 over negative 2, which is just equal to positive 3 over 2, which we expect according to cast, right? Tan is positive here, so it makes sense that we're getting a positive answer, right? And then the last one, we're asked to figure out the cosine ratio of 180 plus x. So we could kind of look at this using the diagram, right? So if you were to add 180 to this angle, you would end up back here, right? And you would have so your triangle would kind of appear here now, where this is 2 units and this is 3 units, so you'd have the coordinates 2 and 3. So the cosine ratio of 180 plus x would be the x coordinate, the x coordinate divided by the length of this radius, which doesn't change, would be root 13. So I don't know if you'd get full marks for doing it that way, but I think that is potentially one way you could do it. But let's do it the reductions formula way. So that would be so cos of 180 plus x is the same as negative cos x, right? And what do we have here? Cos of x is this guy divided by this guy, so it'll be negative 2 over root 13, which gives us positive 2 over root 13, so arrive at the same answer. So let's see if the memo agrees with all of our shenanigans. So sine 30 plus so the memo doesn't actually give us the first answer, it just says that this is equal to this and it ends it there, which is quite interesting. But yeah, it would be equal to that. And then for tan, we end up with 3 over 2, and for the last one, again, they don't give the final answer, which is interesting, but yeah, it would be 2 over root 13. Okay, cool, and that's that on that. Catch you another time for another ramble.